Hello there, this is Aaron Parks, aka Parksy, and I wanted to give you a little lesson on exponents. An exponential function is one that has an exponential base, in this case a, an exponent, x, and this is y equals a to the x. So an example would be, if you had y equals 2 to the x, you could plug in 0, 1, 2, 3, 4 for x, and then y would be equal 2 to the 0th, 2 to the 1st, 2 to the 2nd, 2 cubed, 2 to the 4th, and this would be 1, 2, 4, 8, 16. Because essentially each one of these is 2 times itself this many times. So 2 squared, 4, is 2 times 2. 8 is 2 times 2 times 2. 16 is 2 times 2 times 2 times 2. This one's just 2. And this one is a little interesting, and so I won't spend too much time on that right now. If I apply each one of these points here, at 0 I have 1. At 1 I have 2. Not much has changed. At 2 I have 4. At 3 I have 8. And at 4 I have 16. So connecting the dots, we have something that looks like this. This is what's considered exponential growth. This particular exponential growth can be modeled like this. We start with 2 to the 0th power, where we have 1. Now imagine a bacteria or a virus or something where it basically doubles itself every day. So we start with day 1, it's at 1. Or day 0, it's at 1. Day 1, it turns into 2. Day 2, each of those 2 turn into 4. Day 3, each of those 4 turn into 8. They keep doubling. Here I didn't leave myself enough room, but that is 16 of them. So each of those 8 have turned into 16 now. Let's take a look at something relevant and a little scary. This is data from the CDC website, and these are the new COVID-19 cases in the US since March 1st. This is data that basically means each one of these is new cases since March 1st. Now 0 is from February 27th, or no, 28th. So we started at 2, and as you can see here, it's getting bigger and bigger. Now these are newly confirmed cases every single day. So let's take a look at what that would look like in the calculator, and let's see if I can figure out what the exponential base is. So I'll go ahead and turn on my calculator, go to Stat, go to Edit, and start putting in the data. Now that I put in all my data here in L1 and L2, you can see all that. Okay, then we can go to Stat again, Calc, and then roll on down to exponential regression. This will basically model our data exponentially. So we do that, and there we have it. So this is actually in the form a little bit different than how I presented it. This is in the form of y equals a times b to the x. So b is actually the exponential base here. So this b right here 1.3896 yada yada is going to be our exponential base. This is like the rate of growth, or it's related to the rate of growth. And here is kind of like an initial amount. So we're looking at 7 on day 0. So it just kind of takes the data and fits a line to it. And it's an approximation, of course. So we go to second, stat plot. We turn on plot 1. We can do the type as just the first one here, which is just going to be a scatter plot. And then we have X list, Y list, which are L1 and L2, the ones that we put data in. And then the mark is going to be a little dot here. So you can at least see what the graph looks like if you graph it. Now I'm going to go ahead and put in the equation, just rounded to 3 decimal places. And the little caret here is how you can put the exponent in the calculator. All right, and we'll graph. And so I went ahead and changed my window to basically 0 to 31 days. My Y minimum at 0, my Y maximum at 50,000. So that's why it looks like this. I just tried to fit it into a general approximation of where I thought it would go. So notice how, here's basically like most of the data we had. This one little outlier here is what really started making it even more exponential and fit more into that exponential curve here. So anyways, why don't we take a look at some of the data here. So right now I'm on plot 1. I just hit trace. I'm going to jump over to the line. So here are the days we're looking at. So let me scroll down a little bit. So all right, here's day let's see, like day 20. Okay, that's tomorrow. Tomorrow there'll still be about 5,000 cases reported. As we keep going here, day 21, about 7,200 or 7,300. And then day 22, this is just the 22nd of March, we'll be at over 10,000. Day 23, somewhere in the midst of 14,000. Day 24, 20,000. And, if we just keep going up to this 50,000, we're looking at about March 27th. This is, if we don't, adhere to these social distancing mandates. So this is why social distancing is a good idea, because if we can start to do that, this may still go up exponentially for a little while. This curve may start to subside a little bit and start going down this way. But that would be if we adhere to those mandates as soon as possible. Anyways, this is just one way that exponents can be helpful in your daily life right now. Of course, not all of my videos are going to be about the coronavirus. Probably just this one. All right, bye y'all.